Good day. Today we're going to be talking about characteristics of quadratic functions. So I have a couple of drawings here, and as you guys know, I am not the best artist. However, it will serve purpose for what we need. I have some quadratic functions drawn here, and let's just go over a few things. They're not going to ask you this necessarily in this IXL, but just to put it back into the forefront of our memory, let's talk about the domain for a minute. The domain is all possible x values. So if I'm looking at these arrows on the end, what these arrows tell me is that this function will continue on forever and ever in this direction, and will continue on forever and ever in this direction. So that means that my domain will eventually cover all real numbers. We could also write that as the double struck R. We could also write this in set notation as from negative infinity to infinity. We could also write it as all the values of x, so from negative infinity, all the values of x to positive infinity, and then we have to talk about, well, how does that work? All the values of x will be greater than negative infinity, and we're not going to put an equal sign because infinity is a concept, guys, not a number. And then that means that all of my values of x going right will be less than infinity, and then we have brackets that go around it. So you could see that domain represented in all of these ways. Now, let's talk about the range, and this will play more into our pictures. The range will not be all real numbers. The range will be either from the minimum up or maximum down. Now the minimum we can also call the vertex. We can also call the maximum a vertex. I meant to write vertex here. Okay. So let's look at my first little picture here. When we have a point at the bottom of a quadratic function, this is called the minimum. So if we're asked for the minimum value, we would name the y portion of the ordered pair. We could also say this is the vertex when we name the x and the y of the minimum. Now here I've turned the function over, so this would be called the maximum, and that would be y as well. So everything less than the maximum would be the range. Here everything greater than the minimum would be the range. But if we're again going to name the x and the y, this is called the vertex. Now here I have a dotted line that's splitting my quadratic function in half. We call this the axis of symmetry. Now symmetry, for you artists, you already know what I'm going to say. Symmetry just means that I have a reflection of something on one side or the other. So like if you take your hands, put them together, right? And you open them up, your hands are symmetric because one hand is a reflection of the other. So my line of symmetry would go through my pinkies. Okay? So that's what we mean by axis of symmetry. It is the line that splits the quadratic in half. And it's often represented by x is equal. And we know that because when we graph the x is equal line, it goes right through the x-axis. Now, the last things you need to remember are called the zeros. Now, these go by many names: zeros, roots, solution, and x-intercept. All of those words could be used to refer to where the quadratic function goes through the x-axis. So now, with all of that said, let's go ahead and get through characteristics of quadratic functions. So here it asks us what are the coordinates of the vertex. So here we want to know what this point is. Well, from the origin I go up 1 and up to 3. So my vertex would be 1, 3. Next, it says, look at this graph. What is the y-intercept? So in other words, where does this quadratic go through the y-axis? It goes right here through the origin. So the y-intercept is just 0, because if I made the order pair, it would be 0, 0, which is x, y. So the y-intercept would be 0. Look at this graph. What are the coordinates of the vertex? So we go 2 to the left, so that's -2, and then down to, let's see, this is -5, -6, -7, -8. Look at this graph. What is the y-intercept? In other words, where does this function go through the y-axis? It goes through the y-axis here at -8. Look at this graph. What is the minimum value of this function? So remember, when we're naming the minimum, we only need to name the y portion of the ordered pair. So this ordered pair would be 0, -9. But the minimum is where we have like this invisible line that goes right through the bottom of it. So it'd be at -9. That is the minimum of this function. What is the equation? Keyword, equation. So something equals something of the axis of symmetry. Well, right here, it's the y-axis that is splitting this quadratic in half. So we would say x equals, let's see, this would be -1. X equals 0 right here, x equals 1. So x equals 0 would be our axis. I thought I typed 0. I meant to type 0. Okay, let's try again. What is the equation of the axis of symmetry? This time, I'll make sure my number lock is on. So it'd be x equals, and right here, let's see, -1, -2, -3. Look at this graph. What is the minimum value of the function? So again, it's going right through -9. It's an invisible line that goes and it hits right here. So that would be the minimum value. What is the minimum value of this function? Well, if you think about this, this is y equals -1. So this is y equals 0. So it would just be 0. What is the equation of the axis of symmetry? Again, equation means something equals something. So we know this is going to be x because the line, imaginary, goes through the x-axis, equals, and the equation of this line is x equals -2. What is the y-intercept? Where does this quadratic cross the y-axis? It crosses right here at -2. What is the minimum value of this function? Well, here's the minimum, and it's at -1. What is the equation of the axis of symmetry? Again, the y-axis is splitting this quadratic in half. We know the y-axis is x equals 0. What are the coordinates of the vertex? Well, remember the vertex is, in this case, it's the minimum, but the vertex has to include the x and the y. So we didn't move left or right, so our x is at 0, and we did shift the quadratic of 1, so our y coordinate would be 1. All right, so that's what it looks like to make it to 80. Why don't you go ahead and put it up to 100? Talk to you later. Bye.